Hello everyone, I'm Mojtaba and welcome to another episode of A Sip of Chemistry. Today, I'll be having a friendly conversation with Professor Alicia Duran from the Institute of Ceramic and Glass in Spain. She is a distinguished researcher in the field of glass science and has received several prestigious awards, such as Glass Person of the Year 2019. She has served as the president of the International Commission on Glass and was one of the principal organizers of the International Year of Glass 2022. Recently, in late November 2023, a symposium on glass and sustainability was held in her honor. It's my pleasure to invite you to watch this exciting interview with Professor Alicia Duran. Thank you so much, Professor, for agreeing doing this interview. I'm so excited about that, and thanks for your time. At the beginning, I would love to know about your academic background. Where did you study, and please tell us about your education.
I was born in Argentina, and I made all my career up to the degree in physics in the University of Cordoba, the National University of Cordoba. And I took really got the degree in physics in 1974 in Cordoba, in the specialty of material science, and in particular focus in glasses. Why really? Because we have in the last year of the career, in the fifth year, we had two very good courses on refractories and the glasses by Professor Mari, that from Buenos Aires. And so it was my first contact with glass science and technology, and so I decided really to make the degree thesis in glasses. And so I asked for a fellowship in Spain in the Institute of Ceramic and Glass. I took it, and so this was the idea, and it was my first contact and entering in the glass world.
Okay, interesting, awesome. And was it the university that now you are teaching at? The university that you did your PhD?
No, now I'm not in a university. I am in the Institute of Ceramic and Glass. That is one of the 140 institutes of the Spanish Research Council, CSIC. We have our institute is in the campus of the University Autónoma of Madrid, but it owns to CSIC, not to the university. We we collaborate from many years ago with the university, and taking part in some courses, especially in master courses, focus in materials and in part in glass.
Okay, interesting. I didn't know the details of this educational system in Spain. It's interesting. So, you already answered why you became interested in glasses. You have covered a wide range of research activities like lithium batteries, sealing glasses, and coating for corrosion protection of metals. Do you know any other material that actually have this wide range of applications?
Indeed, the glass really is a wonderful material, covering a lot of applications. not only by the application, but focus in the processing to get the materials. And so you can produce glasses from many different processing. The most well-known is melting and quenching, of course, in which you have the most really expanded applications like glass containers or flat glass for glazings or transport, no, or windscreen. But you can also obtain glasses by other processing, like, for example, by coatings. In this case, in which you modify the surface of a different material to get new applications, is the case for coatings made by sol gel. You can, of course, make coatings by other techniques like PVD or CVD, but we are in our group, we are specialized in sol gel coatings that we have, well, that they are used again for many types of application by the modification of the surface. On one hand, for example, the surface of glass glazings, no, in which you can start from a flint and color glass, in which you can obtain different types of coatings for modifying the optical properties, as the reflection or anti-reflection, but others like self-cleaning, photocatalytic, or photonic application, in which you can obtain really different luminescence responses for increasing, for example, the efficiency of PV panels. No? You can also modify other materials as metals, for example, for increasing and enhancing the corrosion properties, making well, taking care and taking profit of the other applications and properties of metals, but increasing the corrosion resistance of these metals. We have worked a lot in this issue, and for example, increasing the corrosion of light alloys, in particular aluminum alloys, and now we have in the last years working with magnesium alloys. So we can use these metals. They are very cheap and very abundant in nature, with providing the material a very high corrosion resistance. These are really examples of this, of the power of coatings. You can provide, for example, also by coatings other type of properties of like, for example, the bioactivation of the of coatings, also depositing these coatings onto different types of substrates, maybe glass, maybe metals, maybe plastics indeed.
You mentioned about the sol gel glasses, and I know that you actively have been working on sol gel glasses, and one of your articles about silicate glasses, 1986, you published an article about synthesizing a glass uh, using sol gel. So I would love to know about this process more. I mean, uh, have they been commercialized? I've seen many publications in the literature about the sol gel glasses, but my knowledge is limited about their application in the industry. Do you have any idea about this?
Yeah, it's well, the world of sol gel is very, very wide, really. We are working in coatings, but there are many other sectors. For example, for aerogels, well, the aerogels are really perfect isolant materials, and they are very, very used and expanded in industry, really, and with many, many applications. But also, there are many application, industrial application in the sector of coatings, really, and they are in the market from many years ago. Now there are other important applications in other specific sectors like biology and bio coatings and bio applications in, for example, in diagnostic kits and so on, that they are on the market also from well, quite many years ago. We are really focused in the coatings, mainly in corrosion resistant coatings, but also in photonic coatings and photocatalytic coatings. For example, in this case, deposit on glass. But certainly, sol gel is well, quite new, because it was it has less than 50 years of development, but with bigger applications and a big impact in the industry.
How do you see the future of the sol gel glasses? I mean, mainly the challenges and the further applications.
It has really more and more people is entering you know, the sol gel was born in the glass science sector. It arrives in the first 70s in few labs in Europe, looking for a technique to produce glasses at a low temperature, really skipping this problem of the melting that you have to go to 15 or 1700 degrees C to get the material. And so it was really born in the glass sector, and the first workshop was in 1981 in Padova, a call really organized by Professor Gottardi, in which they were only 29 researchers, mainly from Europe. But it scaled up really, and is a workshop that is organized every 2 years, has gathered now around between 400 and 500 researchers in many from many sectors, coming not only from glass, but from chemistry, from plastics, from biology. There are many people working in bio application. So it's rather, well, organic and inorganic chemistry, and there are many people really looking for different applications and different ways to produce sol gel. And so the interest is maintained, really. And for example, the next workshop will be in Berlin in August of 2024. The last was in 2022 in Lyon, and it's going all through the world, maintaining really the interest and the gathering around 500 people.
It's very interesting that you can produce a material which used to be synthesized at elevated temperature, now at, I don't know, 1/3 of that temperature, something like 400, maybe 400 degrees or 300. Yeah,
depends on the type of material. If you are working with inorganic material, as it was born really because the idea was to produce silica, you can produce silica at really bulk silica, pure bulk silica at 1,200 degrees C against the 2,500 degrees by melting, but also coatings that in the case of inorganic coatings, you can talk about 500 degrees C. But in the case of hybrid, that they are very, very interesting material, the hybrid inorganic organic, really in this case, you don't surpass, for example, the 180 really, because you have to maintain the polymeric idea, the polymeric nature of these materials. And so we are always talking about rather low temperatures, and especially in the case of hybrid or totally organic materials.
The last question in this part, I would like to know about the phosphate and borate glasses. I've read always about the silicate glasses produced by sol-gel method. How about borate and phosphate? I think it's harder to make a borate or a phosphate glass using this method, isn't it?
There are not many applications in borate, and because well, they are borate made by, but borate glasses are very easy to fabricate by melting, because it melts at very low temperature, between 500, or if you well 1,000 if you mixing with other oxides. So there are not many borate made by sol-gel, because it has really the sol-gel is most focused really in the case of inorganic materials, in inorganic with high temperatures of melting, like silica, zirconia, alumina, titania, for example, that they are very, very difficult to obtain by melting, and they are quite well, if not easily, because there are many tricks, but you can get really to materials and combination of oxides, for example, that they are very difficult to obtain by melting, you can obtain by sol gel. And so the borates are not really very quite interesting. You have in other, for example, they are being studied, for example, a lot of oxides for photocatalytic application, like zinc oxide, for example, for the idea to prepare zinc oxide coatings doped with other dopants, really to increase the photocatalytic behavior of the coatings. Well, they have a lot of application, from the cleaning of wastewaters, for example, to the self-cleaning of glazings, in which you can degrade the organic pollutants and clean only with water, for example. No? So they are, in this case, for example, they are different oxides prepared without silica, of course, different oxides, titanium oxide, zinc oxide. Zinc oxide is now very interesting, really, because you can dope with the different dopants, like aluminum and other lanthanides, for example, for increasing and enhancing the photocatalytic properties, and adding other properties to this.
Interesting, very informative. Thank you for your explanation. So, you are recipient of several awards. Glass Person of the Year 2019 is one of the prestigious one. Actually, and quite recently, in late November, actually, a conference was going on in Panama, and the focus was on glass and sustainability. And the conference was named to honor you. So please tell us about the conference and how did it go?
Well, quite unusual conference that is organized for honoring researchers in different fields. And in this year, it was one of it's organized in different symposia, and in this case, it was one organized in focusing glass and sustainability. The Congress had my name, but I prefer really to not focus the topics on my career, but in the sustainability of glass. Why we have, we have developed during 2022 the International Year of Glass. It was a great word, a great work, really, that gather the support of more than 2,600 institutions from 96 countries. And it was really a great success. The IJOG, the International Year of Glass, was organized, it was organized first by the International Commission on Glass. It was presented, the idea, in 2019. And when 2018, really, when I took the presidency of the ICG, and it was the idea of contacting United Nations for the possibility of organizing in 2022 the International Year of Glass. I took the challenge and contacted the Spanish permanent representative in United Nations, and the ambassador got the challenge, and so we work a lot during 3 years to get this. A very hard work, because in 2020, when practically everything was ready to be presented to the General Assembly, the pandemic arrived, and it was very difficult, really, because we had to negotiate, really, to get the unanimity of the General Assembly. In this, it's you can imagine the difficulty, really, to arrive to unanimity approval, really, but we got it. We work a lot, and better with the support and the work of many people distributed around the planet. And so we arrive on the 18 May of 2021, just 6 months before 2022, we got the unanimity of the General Assembly, really, with the specific support of 19 countries, really, to get this International Year of Glass. And so it was, there were thousands and thousands of activities organized all over the planet in different fields, from science to technology to industry to education, and very important in art and museums, exhibition, artists, really, that gathered and produced very strong networks that we have now to maintain, really, and reinforce to in the world of glass. It was a very perhaps surprising but very important result of the IJOC, further than the thousands and thousands of activities, was this network, really, that transversal networks between science, technology, industry, education, and art really that were through all the sector and all the people working very, very hard from all the sectors. And this is our current challenge, really, to maintain this networking and maintain the links of this so wide field of glass people, glass world.
Definitely, that was a great job, and you put too much effort and time on organizing all these things. I have a question about the relationship between academia and industry in glass science in Spain or worldwide. Do you have any comment and idea about this relationship?
Wow, this is a very strong relationship. You know that the glass industry is highly concentrated in the world, really, in big companies because well, the investment you need for starting glass furnace is very, very high. So it's the glass capital is very concentrated, and the glass industry has worked a lot during well, the last 100 years, really looking for a better efficiency of the process, really, that you know that glass is made of the most common and usual raw materials like sand or aluminates and sodium carbonates and so on, that they are very, very wide distributed in the planet. But it's a very high intensive process in energy. And so they need high energy consume, and so they also produce very high CO2. So they have been working a lot in the last 80 years, for example, and they have a very strong own labs in the companies, but also a very high relationship with the academia. Now we have, well, in the last 50 years, for example, the energy consumed has decreased in more than 80%. The glass melting is much more efficient, and now from in the last decade, they are big effort really to reduce more this by a revolution in the design of furnaces, for example. And so by changing on one side the fuel from gas or fuel directly to green energies and pure hydrogen, for example, and also by introducing the electrification in the furnace. The electrification is very well known from from the 19th century, but now but is used really for small furnaces, and so it's now studied how to introduce this in big furnaces. And so they work a lot with the academia for this, for the design and improving on furnaces, but also in new glass applications. We have in our group glass ceramics from for sustainable society. And we have we work in melted glasses, many different, like from photonic glasses to lithium batteries to sol gel, but also this from the academic really point of view, but we have from the very beginning, from for more than 40 years, a very strong relationship with the Spanish glass industry. We have really worked with them, with the companies, individual companies, but mainly with the associations. This is ANFEBI, for example, that is the Society of all the glass containers producers in Spain. We have worked with them from more than 40 years, really, in many topics, mainly, for example, the recycling of glass, but also in enhancing the quality of glass containers and certifying, for example, I think 4 years ago, that all the glass containers produced in Spain have the certification of food safety. They accomplish really and have the rules of food safety in Europe. And we also work with the big association that is called Vidrio España. This is Glass Spain, really, that in which they are all the producers of glass in Spain. We have worked with them mainly in environmental issues, really studying and certifying the best techniques for getting the lower emission standards. And we also work with the individual companies, for example, for enhancing slightly modifying the compositions, really, to get better glasses and more resistance, and with a lower energy consumption. In the last year, in 2022, we have strongly really work with them in the year of glass, because all the glass sector in Spain was really working together in many different activities, really celebrating the year of glass. So we have there is a strong relationship in all the world, really, between companies and academia, and it is particularly stronger in Spain.
It's been always my concern, the relationship between the companies and academia, and how companies can benefit from the people in academia. Thanks for your explanation. So my next question is about the women in science generally. The other day I was reading an autobiography from a female emeritus professor in chemistry. Unfortunately, I forgot her name, and at some point she mentioned about the discrimination she faced during her early career, and also when she was a graduated student. I wanted to know your opinion about this topic, discriminations that women in science may face, and how it was when you started your career, when you were a graduated student, and nowadays. What do you think about that?
Well, the role of women in science has been studied a lot, really, and they are two important metaphors about this. On one side, the very well-known glass ceiling, really, that describe that in the research career, this is the women researchers, really, you can look really that at the beginning of the career, maybe at least in the West countries, it may be similar between 40% the researchers entering in the career, but this percentage diminishes when the career advances. And so there are much less women, for example, in the high positions, usually less than 20%, in some cases less than 10%, in very advanced countries like Japan, for example. And so this is one of the problems of this, that they are the women are discriminated in the research career, and it was described well in the first 2000s by the European Union, really, that identified this problem, and that identified and tested, really proof that it was a very, very wide expanded problem, not only in the South countries, really, but in all the world, including, for example, the most well-known as advanced societies like the Norway or the North Europe. There are many ideas about the cause of this, the origin of this discrimination. This idea of that the British call the All Boys Club, really, that all the researchers act as the men researchers act like a club in which only men enter. They are not a clear network, but they are strong networks that act and identifying and selecting really only men, because they are in the club. And so women are invisible. This is the idea. But there is not the only. This is, of course, a very important one, really, in which the women don't arrive to decision positions, because this is the question. This is the main question, that in all, well, practically in all European, for example, bodies, the women are much less. And so the decisions are really taken, but a majority of men. And this impact in the agenda of research. That is very important, because there are many things in the agenda of the topics in which we have focused, that they will be financed, really, that they are gone, really, by men decisions, really discriminated or ignoring some very important issues. Which is the other cause, really, that women that work in research, and as women working in any other field, they have not only one work. They work in a company, in a body in which they take a salary, but then they have the other work at home.
Exactly, yeah.
In this, they have the strong work that is not recognized by society. That is, we have to look for the children, but also to look for the parents and the elder people.
Exactly.
And this is the main origin of this. I always say that I am in my position, really, because I have no children. If I have many examples among my researcher friend women, really, in which they are excellent researchers, but they had to renounce, for example, to many trips or getting or spending 1 month or 2 months in other university, and strengthening the networks, really. because they are limited by the children, really. Including people in which in the couple the man helps really, but there is a normal limit for researchers, women, not only researchers, but women working in any part of research and STM, research, science, technology, and sector. No? And well, we have to work for this because this is not a problem really of class field or informatic field. This is a problem of society. We have to change the societies, and we will only change the society if we change the education, because this starts in the education where the children learn that about the role of men and women in society. Then we need to work in a co-educational system in which the roles are totally shared by this. This is the only. This is a long way, but we need to get it. Why? Because it's so clear that an economic or scientific or any type of system cannot be efficient if it is ignoring half of the work power. This is simple. You have really, this is simple, not the most efficient system, because it has a lot of studies and that demonstrate really that the gender equality and the groups in which they are women, and not only women, people from other countries, the diversity. If you if you can really manage the diversity, including gender, of course, the results of the groups are much better, really, in economic also, because the companies get more money for this and for solving the problems. Really, this is proof, but this is a challenge in which we have to work. But this is one of the idea. We have, of course, increase the number of women and the number of diversity. This is people from other countries, other costumes, other ideas. Really, these groups are much more efficient. And we need that much more women arrive to decision positions. This is a key. This is the key goal. But on the other side, and also link to the same problem of the cares, really, of the is the other metaphor, that is the sticky floor. So what does it mean, really, that in the lower positions, in the lowest positions, really, there are a lot of women that enters in this position and never goes up. This is why, and they are the lower salaries and the part-time and so on. They are the lowest scales in which women enters and they stay there forever. So this is the other problem, really. We have to work on this, not only for making justice to women, that is, of course, very important, but for arriving to a better efficiency. In our world, for example, of class science, we are working from really from in the last 10 or 15 years, really trying to make visible the work of researchers, women researchers in glass. And for example, we have published special issues of journals like the IJAX, the International Journal in Glass Applied Science, for example, in which they call, for example, women in glass, really, but also we are working trying to arrive to a parity in the invited talks, for example, in congresses, because you arrive and you can see that women are more than 40% of the attendance, but they have 10% of the invited. So we are trying really to get to, with different measurements, to arrive to parity, because the problem is that they are invisible, but they are many. And we have constructed, for example, a list from more than 100 women researchers in all the world, in every country, really making a very good work, and that they are ignored. So for all the glass events, we send this list, and we have, if you don't know, you have here, and you have many people from your own country really working there. So we know it's a very long way, but we have to run it.
Yeah, thank you so much for your explanation, for your thought. And yeah, it's so sad that it happens. And you mentioned that it's because they work at home, they have to be a good researcher, they have to be a good mom. Yeah, and it's really hard. And I hope that we, all of us, we go in a way that we remove this discrimination against women. You are the president of the International Commission on Glass, so it would be great if you could tell us more about this committee, its history, and its missions.
I was the president. I was the president of the International Commission on Glass from 2018 to 2021. And the ICG is the most important association in the glass field, gathering scientists, technologies, industrial educators, and art. It goes through. We have in this moment 32 countries represented, and many, well, all the big glass industry and the main glass researchers are there, really. It's a very old association. We have accomplished this year 90 years. It was founded in 1933. Really, and it's the most important glass association in the world. We organize a national congress, an annual congress coinciding with a national congress on glass in any of the MPOs, the representative, and we have an international big congress all the 3 years. The last one was last year, 2022, in Berlin, in which the DGG celebrated the 100th anniversary. And next one in 2025 will be in Calcutta, in India, really.
Okay.
The association has also 23 or 24 technical committees in which we have more than 500 experts from all the world really work together to solve different problems, constructing, again, a networking for searching together really all around science, basic science, applied science, or industry.
So you attend last year in Germany, yeah? Did you attend last year?
Yes, of course.
Yeah, great. How did it go?
Well, it was very important. It was 850 attendance, many young researchers. It was really focused. This is a common challenge in the glass sector, to get young people, very brilliant, really, to make the glass, to show that glass is a wonderful and very interesting world in which young researchers, young technologies, glass industrial can really manage and develop a bright career.
Okay, so can you just tell us a few challenges that you see as a glass scientist in this field? What are the main challenges? If you, right away, if you want to design a project to address one of the challenges in the glass science, what it would be?
One very important is education. Of course, we have to try to extend really the educational model. 30 years ago, there were a lot of glass centers in universities and many glass courses. This has decreased a lot in the last decades. But we have two strengths, is really maintaining and improving the role of glass in material science courses. Of course, giving changing perhaps the old courses and giving the important and more new applications of glass, that there are many, really, from biology to photonics, for example, for glass fiber, photonic glass fibers, or to construction and smart glazes. There are many, many, but we need specific efforts, really, to arrive to the ideas of young people, really, to get this. I think this is the main aim in this moment, education and getting young people for the glass world.
Okay, awesome. I have so many questions, but I don't want to keep you late. I'll move
Yeah.
to other questions, I mean, non scientific questions. What was your dream job when you were a kid?
Well, when I was a kid, really, and practically up to the end of the bachelor, really, the college, I was adapting, really, because between teaching, really, and science. And really, I got the two titles at the final of my bachelor. That was teacher, really, and but I selected and I decided to work in science, and so I made my career in physics and also entering in the glass. But I always like and I also love teaching, really, and for this, really, I think that education is a very, very important issue to develop. Of course, the glass one, but education is in the basis of constructing a better world.
Another question about your job. In an imaginary world, what would be your job? Let's say in another parallel imaginary world, you can choose another job.
Well, I think that I would select the same job.
Okay, awesome. Again, you would like to be a teacher.
Yes, I love glass, really, and I think it's a very rare, strange material, because there is a feeling that all people working in glass, in any type of science, technology, industry, or education or art, really, people fall in love with the material.
Yeah.
And so this is the origin, this is the cause of this great support to the International Year of Glass, and the great work done real in this. And so I maintain really my love for glass, and surely I could select the same job.
Okay. So, what do you do at your spare time? What are your hobbies?
Well, I have many hobbies. Well, the first reading. I read a lot, really, and I love the travels. I have many trips because of my work, my professional work. But I love really knowing other cultures, other people, other countries, but always this is very important for me. I don't like really traveling only looking at the and the buildings and the monuments. I like to know people really, and I think I don't know any country if I don't know its people, the markets, and how they live and how they feel, how they think. Really, this is the traveling for me.
Yeah. Do you have any regret in your career? I don't know.
Well, I think I would in a new life. I could make I could face and solve some things in a different way. But
Yeah.
really, I don't regret on
Awesome.
my important decisions. And so
Excellent.
I could
Excellent.
select again the first the same job
Yeah.
because in any age in any world. I'm sure I could be I could love glass.
Awesome. Excellent. So, is there any other thing that you would like to talk about? I didn't ask.
No, I think it's enough, and I thank you a lot for this interview.
No problem. Thank you so much for dedicating your time, and thank you for being patient with these technical difficulties. And hopefully, I see you sometime in Argentina or in Spain.
Okay, bye
Merry
bye, and
Christmas.
thank you
Yeah, Merry
again.
Christmas.
Bye
Bye bye. Bye.
bye.